In the extreme environment of atmospheric reentry, spacecraft face temperatures that would melt conventional materials. The challenge of protecting these vehicles has long been a critical obstacle in developing truly reusable spacecraft. But what if the spacecraft could cool itself the same way humans do, by sweating? That's exactly the revolutionary approach being developed today. A groundbreaking research team from Texas A&M University has partnered with Canopy Aerospace to develop what might be the future of spacecraft thermal protection. They're creating a remarkable 3D printed material with a unique capability. It can sweat coolant gas to protect spacecraft from the searing heat of reentry, allowing them to land ready for another mission without extensive refurbishment. This innovative design utilizes a method called transpiration cooling. When activated, the system releases a layer of gas along the vehicle's surface that serves two critical functions. First, it directly cools the spacecraft structure. Second, it creates a protected barrier that prevents direct contact with the intense heat generated by friction and compression of atmospheric gases as the vehicle slices through Earth's atmosphere at hypersonic speeds. Gas has a very low thermal conductivity, explains Hassan Saad Ifti, assistant professor of aerospace engineering at Texas A&M. This is why a puffer jacket is so effective. It traps air in these pockets, so it is the insulation from the air keeping you warm, not the solid part of the jacket. This same principle works in reverse to keep spacecraft cool during the extreme conditions of reentry. The implications of this technology could be transformative for space exploration. Current spacecraft rely on either single-use heat shields that burn away during reentry or heat-resistant ceramic tiles that require extensive inspection and replacement between flights. Both approaches significantly limit the true reusability of spacecraft, creating lengthy turnaround times and increasing costs. The transpiration cooling system could eliminate these issues, making spacecraft more fully and rapidly reusable. The material itself is a technological marvel, a 3D printed silicon carbide developed by Canopy Aerospace. It's engineered to maintain structural integrity under extreme atmospheric pressures while remaining porous enough to allow coolant to sweat through its surface. This delicate balance of strength and permeability is crucial to the system's effectiveness. William Matthews, a fourth-year PhD student leading the testing efforts, describes what they're looking for. We should see that the material's surface is cooler at hypersonic speeds when the coolant flow is introduced than the baseline when no coolant is present. These tests will help determine the technology's potential applications and future development directions. The research represents more than just an academic pursuit. It's backed by a substantial $1.7 million Air Force Small Business Technology Transfer Grant, highlighting the military and commercial significance of developing more efficient reentry systems. As space activities increase, from satellite deployments to human missions, the demand for spacecraft that can quickly return to service becomes increasingly critical.
Imagine a future where spacecraft return from orbit, land, and after minimal servicing are ready to launch again, similar to how commercial aircraft operate today. This sweating technology could be a key enabler of that future, dramatically reducing the cost and complexity of space operations, while opening new possibilities for exploration and development beyond Earth. The technology also reflects a broader trend in aerospace engineering, looking to nature for solutions to complex problems. Just as human skin uses evaporative cooling to regulate temperature, these next-generation spacecraft will use a similar principle to survive the most extreme environment humans have ever operated in. As we continue pushing the boundaries of space exploration, innovations like transpiration cooling demonstrate how creative thinking and advanced materials science can overcome seemingly insurmountable challenges. The development of spacecraft that can sweat represents not just a technical achievement, but a significant step toward making space more accessible and sustainable for future generations.